Hello children, this is Yuranjit sir. We are studying 8th standard mathematics under the topic rational numbers. In this video, we will be introduced to this topic and our video will cover exercise 1.1. The subtopics are definition of rational number, rational numbers on a number line, and absolute value. Capital Q is the symbol for rational number. The definition of rational number states that a rational number is a number that can be in the form p by q, where p and q are integers and q is not equal to 0. I repeat, a rational number is a number that can be in the form p by q, where p and q are integers and q is not equal to 0. Let me give you few examples. -3 by 4, 6 by 7, 4 by 9, -2 by 5, 10 by 3 and -17 by 7. When you look at these examples, you can recollect that these are similar to that of fractions. Now, let's learn how to draw a number line for rational numbers. In all the other number system like natural numbers, whole numbers and integers, we will simply draw a single number line and plot the needful points on it. But drawing number line for rational numbers are quite different. You need to draw a number line based upon the denominator of the rational number. Let me explain to you. This is a normal ruler. This is a 10 centimeter ruler. Each centimeter is divided into 10 millimeters. This is an example of a number line. Let's see where 0 is. It's here. And where is 1? It's here. Now let's take an example. 5 by 10. Why have I taken 5 by 10 as an example? Because between 0 and 1 we have 10 divisions. So this number line can be used to plot points whose denominators are 10. So I have taken 5 by 10. So where does 5 by 10 lie on this number line? It's very simple. Once the number line is drawn based upon the denominator, you have to check the numerator. The numerator is 5. So count from 0, 1, 2, 3, 4, 5. So this is the position of 5 by 10. Let's take another example. 23 by 10. Where will this 23 by 10 position itself on this number line? You have to count 23 lines from 0. As you count from 0, the 23rd line falls here. So the position of 23 by 10 on this number line lies here. Let's take another example. This is a different number line. Between 0 and 1 and 1 and 2, we have actually 8 divisions. It means you can plot rational numbers whose denominator is 8. Let's take an example. 3 by 8. Where will this 3 by 8 lie on this number line, children? It's here. Why do we say that? Because the numerator is 3. You have to move 3 steps from 0. When you move 3 steps from 0, 3 by 8 lies here. Let's go to the next example. 6 by 8. Where will 6 by 8 lie on this number line, children? Here. Why is it so? This is the sixth line from 0. This is the position of 6 by 8. The third example, 8 by 8. 8 by 8 falls here, exactly on 1, because 1 is the 8th line from 0. Let's take another example, 13 by 8. The 13th line falls here, so this is the position of 13 by 8. Let's go to another example, children. These are few lines. I position 0 here, 1 here, and -1 here. I have divided 0 and 1 into 4 equal parts. But you could see only 3 lines. This is a very important point, children. When you draw 3 lines, it means the place will be divided into 4 equal parts. So to divide the given place into 5 equal parts, you need to draw 4 lines. To make it as a 10 equal parts, you need to draw 9 lines. So let's get into this. Since I have divided 0 and 1 into 4 equal parts, I can plot rational numbers whose denominators are 4. Let's take an example, -3 by 4. This -3 by 4 should be positioned in this number line. As we do in integers, when you have a negative number, we will move from 0 towards left. In the same way, if you have a negative rational number, you have to move towards the left. How many steps you need to move, children? 3 steps, because the numerator is 3. So it falls here. This is the position of -3 by 4. Let's take another example. 1 by 4. Where does 1 by 4 lie, children? It's here. Why is it so? Because 1 by 4 is a positive number, so it has to move towards the right. The position of 1 by 4 on this number line is here. What does this teach us, children? Whenever a positive number is given, you have to move from 0 towards your right. If it's a negative number, you have to move from 0 towards your left. Let's take another example. 4 by 4. Where does this 4 by 4 comes, children? It comes here. This is the position of 4 by 4. When you count 4 steps from 0, it lies here. Absolute value of rational number. The definition of absolute value of rational number states that the absolute value of a rational number is a number itself, regardless of its sign. The distance of a rational number from 0 on the number line is called its absolute value. The distance is always positive, so absolute value is always positive. Let me ask you, children, have you ever heard someone telling you that I walked -5 kilometers from my home to reach the school? Have you ever heard people telling you that, hey, yesterday I brought a newspaper of length -3 centimeter? No. Whatever example we give, related to distance or measurement, it will always be positive. So absolute value is nothing but the distance of that particular number from 0. The symbol given here, the two lines, the blue lines, represent absolute value. We call it as modulus. Let's see the examples, children. Our first example is minus 2 by 5. Minus 2 by 5 is a rational number. The absolute value of minus 2 by 5 is 2 by 5. The absolute value of minus 1 by 2 is 1 by 2. The absolute value of 5 by 7 is 5 by 7. The absolute value of minus 4 by 27 is 4 by 27. And the absolute value of 11 by 6 is 11 by 6. What do we understand from all these examples, children? The absolute value of a rational number is the number itself regardless of its sign. Thank you so much for listening, children. If you have any doubts, you can contact me and clear your doubts.